Hello and welcome back to Data Analysis and Visualization. I'm Jovita Christie, and in this video we are going to talk about time series, which is another important tool to um, perform data analysis and visualization. So let's begin. First of all, we'll begin with what a time series is. So a time series is just a collection of data on attribute values over time. So it could be just data, number of sales per day or something, and that data you're just plotting, and that could be a time series. Time series analysis is performed in order to predict future instances of the measure based on the past observational data. So it is basically plotted and recorded in order to know how things will happen in the future. So by seeing past observational data, you'll be able to make predictions about the future, and that's why time series analysis is needed. And if you want to forecast or predict future values of the data in your data set, you can use time series techniques. Now, there are different kinds of time series, and the first one is a constant time series. And as you can see, this is the graph. You don't really need to know what's going on X and Y axis. You can just assume this is a sales data time series. So what happens here is in a constant time series, it remains roughly at the same level over the time, but they are subject to some random error. So you can see here that the time series is quite constant over the time. You can see this orange line going here. So it is a constant series and it does not change based on anything. There could be some random errors, but most of the time it's a constant line. So that is a constant time series. Another type of time series is known as a trended time series, which shows a stable linear movement up or down. So you can see it's almost like a linear regression line, which shows either an up or down slope. And in this case, this line is going upwards. There could be a line going downwards. So either way, it's a linear movement. And whenever there's a linear movement, it is a trended time series. The next is a seasonal time series, and here you can see there are two kinds: untrended seasonal time series and trended seasonal time series. So let me just go back a bit and tell you a little bit more about, let's take a look at those graphs once again. So you can see this one is it's untrended seasonal time series, which means there is no trend involved. So you can see it's almost a constant rising and falling. But when you see this trended one, you can see a sort of a slope in this thing. In this, you can see it's going from down to up, and this one's just constant. So there is no trend in this, but this one's got trend. So this is a trended seasonal time series. Now, whether constant or trended, time series may also sometimes exhibit seasonality, predictable cyclical and fluctuations that reoccur seasonally throughout a year. So this is seasonality comes obviously from seasons, like we have winter and summer and monsoon. So in the same way, there are predictable cyclical fluctuations that could occur throughout the year. Like, sales could go high because of some, let's say, Christmas season or some sort of a festival season, and that could affect our time series. That is seasonality. And as an example of seasonal time series, consider how many businesses show increased sales during holiday season. Like I said, like Christmas season, you'll see an increased sales. So although your time series could be constant or trended, you might see that there is some rise or fall during some time in the sales. So that is a seasonal time series. Now, if you're using or including seasonality into your model, you should incorporate it in the quarter, month, or even 6-month period wherever it's appropriate. So you have the choice to incorporate this seasonality wherever you like. So you can incorporate it wherever you want, either quarterly, monthly, or 6-monthly or bi-monthly. Time series may show non-stationary processes or unpredictable cyclical behavior that's not related to seasonality as a result of economic or industry-wide conditions. So even the economy plays an important role in the way the time series looks. And when it comes to economy, it could be that the time series is showing some fluctuations, but that's not because of some holiday season. It could be just the economy either rising or falling, or some industry related issues, like maybe some product is just doing very well right now, and at some point there's a less demand, so the product's not doing so well. So this is a seasonal time series. Now, since it's not predictable, non-stationary processes cannot be forecasted. You must transform non-stationary data to stationary data before moving forward with an evaluation. So like I said, sometimes there could be fluctuations that are not usual fluctuations, and that's why when the processes are non-stationary, you cannot perform forecasting. So if you want to perform forecasting, if you want to perform an evaluation, then before moving forward, you have to transform your non-stationary data into a stationary data to perform further evaluation. Now, how do you model univariate time series? So similar to how multivariate analysis is the analysis of relationships between multiple variables, univariate analysis is a quantitative analysis of only one variable. And when you model a univariate time series, you are modeling time series changes that represent changes in a single variable over time. For example, the sales of some particular product over time. So when you're just analyzing that, then it's a univariate analysis for which time series would be the most suitable option. Now here are some formulas and mathematical models for your reference. You can see this is how time series are created. And after this, I'm going to take you and show you a little bit of Python code on how you can do time series analysis. But before that, let's just review these formulas one by one. So this is the time series type and the mathematical model. For a constant time series, the formula is yt equal to b plus random error, where yt is the observation at the tth time period. So it depends, are you doing a day-wise analysis, or for a particular day you're doing an hourly analysis. So it's all dependent on that. And a and b are constants. So here we have only b, so there's b is a constant value, and t is equal to small t is equal to 1, 2, 3, which is the time period. So like I said, 1, 2, 3 could mean first day, second day, third day. It could also mean the first hour, second hour, third hour. Depends on how you're analyzing. And here Si is a seasonal constant for seasons. For example, I is equal to 1, 2, 3, 4. So there are 4 seasons, and it is a seasonal constant. And wherever it's written, sigma I is equal to 1 to 4, which means there are 4 seasons, and you're putting I raised to I, which is equal to 1. And I raised to I is either 0 or 1. So the trended time series type has this type of formula, yt equal to at plus b plus random error. Constant seasonal time series would have this type of formula, yt is equal to b. As you can see, you're borrowing the formula from constant. So you have b plus, there will be always random error, but in between we are adding these things, which are the season and I. So that is the constant I. So S1 I1 plus S2 I2 and so on. There are 4 seasons for us, so we are putting 4. And then trended seasonal, would be borrowing from the trended one. So you have 80 plus b plus random error, and in between all these seasonal constants are added. And if you have a cyclical time series and the cycles are here, of course, unpredictable, then you cannot possibly model it using a mathematical model. So now let me take you to a little bit of Python code in order to program this type of a time series and to understand how a time series works. So once again, I am using Google Colab to run my Python Jupyter notebook. And you can see here, this is my Python Jupyter notebook. And you can also run your code directly in Google Colab. That way you don't have to download any software. You could install Jupyter notebooks in your computers and then use them directly if you wished to. But you could also just do it in the Colab notebook as I'm doing it, so you don't have to install. So I'm just showing you very quickly how you can create a time series on your own. So this is not created based on real life data. This is just a dummy time series sort of created. So you can know how easy it is to create a time series. And if you had actual data, you could create a time series for that as well. So we will be using the Pandas library, as you can see, and the NumPy library. And we're just using a date time function later on. So first of all, let us create a Pandas series that logs the time every hour from 1st of November 2019 to the 7th of November 2019. So how to create this? If you already know the Pandas library, you probably already know how to do this. And I am going to do a series of lectures on Pandas soon, but that would take a little bit more time. So right now I'm assuming that if you're in this course, if you're trying to study data analysis and visualization, you've probably studied this before. So you probably studied Pandas and NumPy before. So this is the Pandas series that I'm trying to create for all the times every hour from 1st November 2019 to 7th November 2019. So I'm writing PD, which is basically what I named the library while importing it. So pd.date underscore range. Date underscore range is the function that would create this series. And then the start date is 11th November, sorry, 1st November 2019. The end date is 7th November 2019. And the frequency is equal to h. This h, of course, specifies that you want this every hour. And then I'm just going to print df. So you can see this is the output. Let me run the code once again. Although I've run it before, I can run it here again and show it to you. So you just have to press that button right there to run the code. And if you wish to try it out on your own, then feel free to pause the video and go ahead and type the code in your Google Colab notebook and run it and then come back to this. So this is the date time index, and you can see it's created very beautifully. This is the first date, 1st November 2019, and it's the 0th hour, so basically 12 a.m. And then there are minutes and seconds also given. So you can see that. So this is the 0th hour, and then this is the second. You can see it just continues. It keeps going to 1. And then you can see the 2nd hour, the 3rd hour, and there are 24 hours in a day, so it will continue like that. You can see, and you can see dot dot dot, which just means that there is more data which you presently cannot see. Okay, so this is the date time Pandas series created. Now, the ISO 8601 format for date is year, month, date, then hours, then minutes, and then seconds. And that's basically what you see here in the series. Now, let's see what is the length of this series we created. So you just have to write len, which is a built-in function in Python for length, and pass df. It gives you 145. Let me run that once again. So 145 is the length of this date time index that we created. Now we are going to turn this series into a Python, into a Pandas data frame. To do that, you will use the data frame function from PD, from the Pandas library. So pd.dataframe is the function with DNF capital. And in bracket, you're going to pass the series that you want to convert, which is df, which was the variable we used here, df. And the columns is we are passing as is equal to date. So we are passing this. We want the column to be equal to date. So that is how this thing is working. So you can see here, date is the column. Date is the name of the column that we want to give. We want to name all these things we are storing under one column, but we want to name that column date. So it is date. And next we are going to add one more column, a made up column sort of. Actually, the whole series is made up. So we are going to add one more column called sales. And you can see here df sales, which we are adding to our original data frame. And in this, we will be adding some random values from 0 to 1000 to show sales. So you're going to use the numpy random function. So it is np.random.randint. We are passing the values between which we want these random values to appear. So 0 and 1000. And what is the size that it has to fill? It has to fill this 145 length. For every one, for all entries in 145 length series, we want some random sales value. So we are using len df. Once that is ready, we are just going to do df.head, and that would essentially print this this whole series. You can see df.head will print these first 5 rows of your data frame. And you can see now there's a random value of sales attached to it. Now let's see how you can select values from this data frame. So if you wanted to select a particular date, then you would just, in order to do that, first of all, you would have to assign. You can see this series right here. And once again, feel free to pause right here, run the code on your own, and then come back. Let me run this code and show it to you. I haven't done that. So yeah, this is, you can see the sales different now. Earlier it was some 591 value because it's random, so you can get different values now. So this is the sales value right now. And here, the data frame is indexed by these indices 0, 1, 2, 3, 4. But it could be also indexed by using just the date. And to do that, you just have to write this thing over here that is df equal to df.set_index date. So this is the function that will set date as the index, not 0, 1, 2, 3, 4, and so on. So now when you print this data frame, you can see that this index of 0, 1, 2, 3, 4 is gone, and now you can see date as it is, as well as sales. So now when you want to refer to a particular row, you're going to use the date column directly as an index value. So it's more like a dictionary now. Let's run this. So you can see it's running perfectly fine. All the sales are the same as we received in the previous one. So feel free, once again, you could pause here, try to implement, and come back to the video. Now the next next thing we are going to see is how to index specific dates. So first of all, this is the function which we are going to use, which is .loc. Now selecting using date and getting exact value for a cell. So for example, I want to get 1st November 2019. I want to know the sales for this particular hour, the 3rd hour. How do I do that? I just have to write df.loc, and in the box brackets, I will specify the date, the time, and the exact column that I want, which is sales column. So Here I'm getting 850 because this was the one that I ran previously, but now I would be getting a different value. So you can see now I'm getting 938, and if we go back to our series, you can see the third hour was indeed 938. So you can get 938 here. Now let us see how you can use date to return the row corresponding to that date. So if you use df.lock and you want to get this entire row, then you'll just omit sales, which you wrote previously. You'll just write this thing without sales, and you can see it returns to me the entire row as sales 850 and also gives me the name and the data type. So let's run it, and I should be getting sales 938, which is the case here. Now, how to select an entire day? I don't just want one date at a particular hour. I want an entire day. So I'm going to do df.lock, and you are free to use date directly without specifying the time. So I'm just specifying the date 1st November 2019, and you can see the result right here. So this is the result of that. Feel free to pause, do it on your own. So this is the result. What it shows is all the hours from 0th hour to the 23rd or 24th hour of 1st November 2019 and all the sales. You can see it goes up to 23 because after that the 0th hour will be of the next day. So everything associated with the 1st of November 2019, all the sales are available. So it is very easy to do this by just writing df.lock and specifying the index as the date for which you want the sales data. Let's run this as well. And you can see this also runs perfectly fine, and you could also try it on your own. You could also select dates by specifying a range. If you wanted to find out sales between a particular range, then you could do that by just doing df.lock and specify the starting date and the ending date between which you want the sales for. So my starting date is 1st November 2019, ending is 2nd November 2019, and what you see here are the sales between that time. So starting from the 0th hour of 1st November 2019, I will get all the values up to 2nd November 2019, 23rd hour. You can see it is 8:41 right here. And let me run this as well. Okay, so these are the updated values because we are using random values. So these are the updated sales values. You can try it for yourself. Now you can also do something called resampling for this type of a time series. Like you could apply functions like mean, sum, count, min, max, which are all statistical functions available with Pandas. So you could do that directly. Now there are two things here. One is called downsampling, another is called upsampling. So downsampling is to reduce the date time rows to longer frequencies. You want to reduce the number of rows. Upsampling is increasing the date time rows to shorter frequency. Let's see what that means. So first of all, let's say I want to get average of each day per hour. Okay, I want to get the average of each day per hour. Then in that case, I need to do this. I have to do df.resample, and then this D here stands for day. So D stands for day, and then I'm just doing dot mean, and it gives me the average for that particular hour. Let's run this. And you can see this is the average for that particular day. So on this day, 1st November 2019, the average sales for any hour would be 3397.125. So that's how this thing works. Now, this was upsampling. You can also do downsampling by getting the average for each minute. Okay, because if you want to do that, then you just have to write T instead of D. D stands for day and T stands for minute. So for each minute, you'll just do df.resample T and then dot mean. Now let's run this and then I can talk about it. So you can see there is value here, and other than that, I'm just getting this NAN, and here you have 211. So the reason for this is we have an hourly basis data. So we do have data for this row, which is the 0th hour, but we do not have any data for the 0th hour 1 minute row. So which is why we are getting NaN. You could verify that right here in this data, in this series we printed, that for 0, 0, 0, 0, 0, 0, the 0th hour, we have sales, but we do not have any data for the 0th hour 1 minute because it is hourly, that's why. So due to that, we cannot write it in that way. Due to that, we are getting NaN, but that's all right. I just want to show you what resampling means. So you can get data like this. But essentially, this would work if you had minute-wise data. But since we have hour-wise data, it does not matter. It's just going to give you the same value, which is available already. And these are the resampling frequencies right here. Okay, so if you want to resample by the minute, you would use T, by the hour H, by the day D, business day B, week W, month M, quarter Q, and year is A. So this is something that you can use and explore further. And I hope you understood time series. And I'll be back with the next video, so I'll see you there, and thank you for watching.